All right. In the previous lesson, we discovered some ways in which the functions can be represented. Graphing, ordered pairs, table of values, mapping, arrow diagrams. That's all review. The function from a set D, the domain to a set R, the range is a relation in which, here we go, each element of D is related to exactly one element of R. If you remember from Friday, if you have an X value, it's only going to be a function if whatever X value you choose has only one Y value, or each value of the input has only one output. So you can't have the 0.3 and 5 and the 0.3 and -2. Is there a test to discover if something is a function? Do you remember that test? The vertical line test. Explain that. What is the vertical line test? So we have a picture. So you'd always have some kind of, well, not necessarily a picture. You could make a picture. So if you had this picture, is that going to be a function, this parabola? Yes. How do you know? Right. If you draw a vertical line anywhere on this graph, it only touches at one place. That means for every X value, when X is 7, for example, if we were 7, you only have one Y value. See it? Okay. Then it says, consider the function f of x mapping to 2x plus 3. So if I say, okay, I want to put a 5 in there, then everywhere you see an x, you're going to put a 5 instead. So this x turns into a 5. You see it? 2 times 5 is 10 plus 3 is 13. So we say the value of the function is 13 when x equals 5. Okay. I'm just going to skip down here. I just want you to look at the comparison of each of these. So mapping notation has a little arrow in it like that. And it says we're going to call this machine f. Okay? It's the f machine. That's the function. And it's going to have x in it. And I know. And so x, this is what we're going to do to the x value. We're going to times it by 2, whatever x happens to be, and we're going to add 3 to it. Okay? Then you have this, so you'll see what happens. So we're going to plug 5 in there. How about over here when it's 2x? When we do it like this. Okay, f, here's what's confusing to some kids. Before, when we put parentheses around that, that meant take f and multiply it by x. That is not what we mean when we talk about function notation. What we mean now is f is the name of the function. It could be g or x or g or k or p or whatever. F is the name of the function, and what's in parentheses is kind of like a little note. It's like a parenthetical phrase that you stick in an equation or in a sentence just to give you a little bit more explanation. That's all that parentheses means. It does not mean multiply. So this means the name of the function is f, and then they tell you, oh yeah, we're going to put x. X is going to be what we have in the function. So we have it could be, you're going to see g of t. That means the function is named g. Oh yeah, and I just put little parentheses in here. We're going to be talking about t. So maybe this would be gasoline and time, and I would have some thing over here with a t in it, okay? So the parentheses with the t is like a parenthetical phrase that just tells you what we're going to be talking about in this function. It does not mean multiply, okay? So we say f of x. F is a function, and we're going to be putting x's into it, f of x. Okay, this is what you're used to seeing. You're used to seeing the y equals 2x plus 3. That's how we've always done equations before. One little change. Now we're going to name the function, and we're actually in the name, we're going to tell you what we're dealing with, the f of x. This f of x, by the way, everywhere you've known it before is just like the y equals. Okay, just one little notation change is all we're doing. Okay, so here it is. F of x does not mean f times x right there. Doesn't mean that. Don't do that. Doesn't mean times. The name of the function is f. F is the name. All right, so if we come down here, look at your next page, turn the page. It says consider the function f of x is equal to x squared plus 5. Now, here's what this means. The function's name is f. And then I have a little x inside. I'm telling you that we're going to be talking about x. And then this part of the equation over here, the x squared plus 5, tells you what we're going to do to the input. So according to this little example here, I'm just going to figure out how to do this. This says whatever the input is, square it, and then add 5 to it anytime. Okay? If we're talking about the F machine, all we have to do is take the input, square it, and add 5. because they tell you by definition this particular f machine is x squared plus 5. So when you see this f of 3 thing, they're saying, okay, now we're going to put 3 into our f machine. So what do you think we're going to do with it? Square it and add 5. So we're going to say this equals, write down with me, 3 squared plus 5. Where we saw an x before, now we see a 3. Simple. You get 9 and 5 is 14. Okay, then we move to g of 1. Well, what's the g machine say? It says take 4 and then subtract whatever your input is. It says 4 take away x. So I look at this and I say, okay, well, g of 1, what is my x value? 1. So I just copy, and I just replace. Everywhere I see an x, I put a 1 instead, and I get 3. So g of 1 is 3. All right, let's evaluate f of negative 2. What do? You look at your f machine. What does it tell you to do? Take your input, x, square it. So in this case, it's negative 2. I'm going to square it and add 5. What's the answer to that? Yeah, 4, right? Plus 5 is 9. Is this very hard? No, I hope not. Okay, so this says look at the G machine, take a negative 2 and do whatever you're supposed to do with it. So my G machine says write down a 4, write down a subtract sign, and then put your x value in, doesn't it? Isn't it 4 take away whatever x is? So notice how I'm going to have 2 negative signs here. Watch those carefully. See it? So your answer is 6. Now lots of you are going to miss that if you're not careful. Okay? This one says, well, find out what f of 0 is and then subtract g of 0. So take your f machine everywhere you see. So your f of 0 is going to be 0 plus 5, right? Then we're going to take away the g machine. G of 0, everywhere I see, I'm going to start with, g starts with a 4. And I take away 0. Do you understand what I just wrote down there? This is the f one, and this is the g one. I just put zeros where the x's were. So you end up with 5 take away 4, which is 1.
Is it the 0 squared?
Yes, it is. Go ahead, square your 0. 0 squared is just 0. All right, you doing okay so far? All right, it says consider the function defined by f of x equals to 5x cubed minus 2x, where x is an element of real numbers. That means you can plug any value of x into this function that you want to. Plug in anything you want. So it says determine f of negative 3. What are you going to write down? 5. We're going to put negative 3 in brackets, and we're going to cube it. Minus 2, and we're going to put the x value in brackets. If your x value is negative, put it in brackets. Otherwise, you'll get your signs wrong. Can you see that? That's pretty small. Okay, order of operations. Cube it first. What is negative 3 to the third power? Be more specific. Negative 27 times 5. You can throw that on my desk, Miles. What's negative 27 times 5? 120. What? Negative 135. And a negative 2 times a negative 3 is a plus 6. So you get negative 129. Yeah. Okay, so everywhere we see an x, we put the input. That's going to be the same for B and C and E and F. Yes, it is. Those are all ways of saying the same thing. The value of f when x is 2. We'll go plug 2 in everywhere. I'm not going to do it right now. You could do it. The image of 7 under f, that's funky words. It means the same thing. It just means x is 7. Okay, go put 7 in everywhere you see an x. An expression for f of a. Oh, what would I do there? What did the a just replace? A is the input, right? So everywhere you see an x, now you put an a. So we would have 5a cubed minus 2a. That's it. Nothing, it's not rocket science. The a is replacing the input, which is our x. F is a little bit harder. What is the input in letter F? Over here. What is our input? 2x. So everywhere we're supposed to do to that whatever we did before to the input. So the definition of f up at the top says write down 5. Then it says take the input and cube it. What's our input this time? 2x. So you must take 2x and cube it. And then if I keep reading my sentence up at the top, it says then subtract. There's a 2 times our input, x. What's our input? Okay, do you see it? Everywhere there was an x before in the equation, now I put 2x. Okay, everywhere I saw an x before, now I put whatever my input is, which happens to be a 2x. Does that make sense then? Maybe? Okay, now you have to do this. What is 2x to the third power? 8x to the third, and that must be multiplied by 5. I'll just put minus 4x there. And then we just finished the math. 5 times 8 is 40x cubed minus 4x. Can you do anything to that now? Is that 36x squared or anything? Oh, you could factor it. But we can't actually simplify. You do not combine those together in any way. You could pull out a 4x if we needed to. It wouldn't really help us. Okay. What happens if we even get more complicated? What about this P? This P machine says, whatever your input is, x, take 4 times the input squared minus 6 times the input plus 1. You understand what that means? Okay, I don't care if your input is a heart or a blob. You just do to it what it says to do. So when I see P of x minus 3, no big deal. This is what you're putting into the machine. So do everything to it that the machine said. It said write down a 4, take your input, and square it. That's what the first part of my machine says. Then it says subtract 6 of those things. I don't care what it is. I don't care if it's a big bunch of stuff or not. And then it says add 1. Okay, Miles, I need you to write that down, please. Why did that just die on me? Come back. Come back. Please come back. What do you suppose? Okay, I did not even touch. My screen is not black. That one is. Shucks. All right. Now, what do you suppose you're going to do on that? Did you get it all written down? Okay, I'll move to the board. Shucks. Okay. What do you think you have to do here? Let's go. Let's go fast. You got to work it out, right? What is x minus 3 squared? It is not x squared minus 9. No, it is not. Go, Noah. Nope, it's not x squared plus 9 either. No, it isn't. No, it isn't. X minus 3 squared means x minus 3 times x minus 3. Don't forget, you people. Yeah. Oh, okay. So I have 4. What do I have in there? What is x minus 3 times x minus 3? X squared minus 3x minus 3x plus 9. Remember polynomials, chapter 5. Then I do the next. Okay, you ready?
You just do minus 6.
Then I go minus 6x and what? Plus 18. Did y'all get the plus 18 on there? Was it a plus when you did it? You're changing the signs. And then plus 1. Oh, boy. It all comes back. And it's on. Yay. So I have 4x squared. Oops, I missed this thing. Hold on. Yeah, I know. Okay, can I put that together as negative 6x in the middle there? So 4 times negative 6 is negative 24x plus 36 minus 6x plus 19. Y'all good there? So now what can you combine? Well, I got no other x's, so I'll leave my 4x squared alone. My negative 24, my negative 6x make minus 30x. And my 36 and my 19 is 55. That is a simplified expression for that. Got it? Any questions? Good. Next. Okay. This is a bit different. Okay, this question is where everybody gets confused. We're usually pretty good till this point. It says determine the value. First of all, they give you the function f of x. It's equal to 10x minus 3. And then they say find the value of x if the function f of x is equal to 47. Where do you suppose I'm going to put my 47? Where the f of x is now. Brilliant words. Where the f of x is now. So, you take this, it's not rocket science. If f of x is 47, everywhere I see f of x, I'm going to put 47. Do you get that? Because f of x, Joy, where's your glasses? Put them on so you can see. Now what? Are you looking for x? Yes, we are. Can you solve for x now? Yes, we can. Add your 3 to both sides. You'll get 50 equals 10x. Divide by 10 and x is 5. Boom. Is that pretty fast? Sorry. Plus 3 to both sides. You get 50. Divide by 10. And you'll get a 5. It'll catch on. You'll be good. Solve the equation if f of x equal to negative 23. Same thing, guys. Same thing, not rocket science. Take your equation. Everywhere you see an f of x, put a negative 23 instead. So let's do it. Negative 23 equals copy, copy, copy. This isn't complicated. See, if you just copy everything down and just change one thing, it's easy, isn't it? So now we can solve. We're like, we've seen this before. I've seen this since 8th grade. We've been doing this for a long time. You add 3 to both sides. You get negative 20. Copy, copy, copy. And the last step, divide by 10. Lo and behold, x is equal to negative 2. Done deal. Okay. You with it? Okay, quick. Well, it says f of x is equal to negative 23, doesn't it, Malachi? So if you, this is like substitution. Who's playing volleyball? Jeffrey and Cal. Jeffrey and Cal are on the same team, and I say, you know what? Kale is the same as Jeffrey. So if Jeffrey's on the court, I can pull Jeffrey out and put Kale in, and nothing will change, right? You're equal. You're equal in value. So that's, you know, you have a rocking team. Hold on. Hey, stop. You know you have a rocking team when you can take anybody on the bench and replace them with someone on the court, and you didn't change the game.
Or a really bad.
True. All right. So in this case, Malachi, f of x is the same thing as negative 23. So everywhere you saw f of x, you just get him out of there and put negative 23 in. Make sense? Okay. Is that coming to you? Okay. Next question. Ready? Now be careful. This says evaluate f of 4. What did the 4 take the place of? X. So due to the 4, what we were doing to the x. So we're going to say f of 4 is going to be equal to 4 squared minus 5, which is going to be 16 take away 5, which is 11. I almost said that. Y'all good? You understand? Now the part B is different. X is not 4 in part B. What is 4? F of x, the whole thing. So where there was an f of x, Victor, Now I can take that equation and put a 4 there instead. So I look at my original. I'm like, get rid of the f of x. Throw him out. Replace him with 4. Big old 4. Do you understand the difference between the two questions? One was replacing the x, and one was replacing the whole f of x thing. Okay, now we do the math. We add 5 to both sides, and you get 9 equals x squared. Square root. So what is the answer? What value of x? Is that it? Yes, plus or minus 3, because isn't it true that you could take a negative 3 and square it and still get a 9?
So do we get a
Yeah.
plus that?
Yes, you will lose marks if you don't put plus or minus 3. Jace.
On question A, what happens to the F4?
He's just there.
You don't do anything with the 4?
No, I put him into the x already. So the f of 4 is equal to, okay, good. Solve the function where f of t is equal to 75. Now is 75 replacing the t? No, it's replacing the whole f thing. The whole f thing, right? Replaces all of it. It replaces the whole f. Okay, so here we go. 75 equals x. Oh, it's not an x squared. What should it be? T squared. Well, shouldn't it be? F of t means instead of an x, we put a t there instead. But then the whole f of t thing, the whole f deal, is 75. So I'm still doing this question up here. Same deal. I'm still doing it. The F machine says whatever your input is, take it, square it, and subtract 5. I'm still doing that. So I put a 75 in for the F deal, and I put a T in for the X. We're all good? Okay, now we got to solve this. Ready? We're supposed to answer in simplest. If you thought your brain was blown, just a minute. Hold on. Here we go. What are you going to do first? Add 5. We're going to get 80 equals T squared. Then what do we do? Quick. Square root. Oh, my word. This is plus or minus. Don't forget the plus or minus. So T equals plus or minus 80, root 80, radical 80. I'm supposed to break this down. Who remembers how do you break root 80 down? What do you do to it?
It's 1 over.
Oh, I get it.
Yeah, but do you know?
No.
Yeah. Okay, Jeffrey, enlighten us. Shh. Okay, listen. What do you do, Jeffrey? What is he thinking through right now? What's he thinking about?
Volleyball chicks.
No. True, probably true. Okay, let's talk about root 80. Okay, stop. Noah.
Wait, is this like root 80 like the same as square root of like 5? No, wait, that's weird.
It's like 1 over
You're
80 squared.
No.
8 and 10 or something.
Oh, 8 and 10 is 80. What are we trying to find? Jeffrey, got anything more?
Can't you put like, you go 20 times square root of 4?
Okay, could I do this? Could I go 4 and 20? Okay, let's go. Hold on. Who can do better? This is a good start, but we can do better. Do better than 4 and 20. Hey, Jace, do better than 4 and 20. He's not wrong. He's just not, it's not big enough.
10 and 8?
2 and 40. Yeah, 420 is good.
Can you do like
6 and 9.
Come on, think.
Can you do 16 and 5?
16 and 5. Boom.
Okay.
How is that better?
Yeah, that looks better.
There we go. Get it. 4 and 20. Now, Kale, let me tell you what would have happened if you used 4 and 20. 4 and 20 wouldn't have been wrong, but when you answered, your answer would be 2 root 20, and 20 wouldn't be good enough because 20 has a perfect square inside. So you have to keep breaking it down, just like reducing fractions. Ashley, listen. Just like reducing fractions. If you don't have it reduce it far enough, you're not done. 20 is not done. There's a perfect square inside 24. Again, So go big or go home. Okay. Now, next lesson. Turn the page. We're going to the next lesson. Yep. It's very short. Okay, ready? Let's talk about graphing it. This is no different than what you've already learned. F of X just replaced, okay, the symbols. We got push-ups coming out your way or what? Okay. The symbol F of X, really, I told you before, just moments ago, replaced something you've already done. What did we used to put? We didn't say F of X equals 3X plus 1. What did we say? Y equals. Exactly. That's all. There's really only X and Y involved here. Okay, so when you go to graph this on your graphing calculator, get your calculator out. If you are told to graph a function, just put it in your Y equals. Please don't freak out. There's a little F of X. We know that's just the name of a function. It's called F. The function is F. Instead of a Y, we have an F, okay? Doesn't matter what letter it is. So take your calculators and plug it in your calculator. Hey, stop talking. Hurry up. Get it in there. I'm going to hit Zoom 6 to be standard Windows. And there comes my picture. So take that little picture, put it on your page. It does not go through 0, 0. It goes through 1. Oh, crud. It goes through 1, actually. Stop. Kale, I hear you. Oh, wow. Got all kinds of funky things going on. Okay, there it is. Use the calculator to sketch the graph of the function. Done. Then it says, okay, so no big deal. We just go y equals 3x plus 1. So graphing is not hard. Just change it, the f of x to a y in your mind and you're done. Next part says, in each case, express the relation given in function notation as an equation. So if I want to write this in an equation, what do you write? Y equals, quick. It's that easy, okay? Y equals. If you want an equation, just rewrite the g of x with a y. Okay, next. Let's go back the other way. Express the equation y equals 11x minus 15 in function notation. What are you going to write? F of x. Okay, we're just going back and forth from equations to functions. They're just very interchangeable, just quickly. All right. Here we go. It says y equals f of x. So you just go f of x equals, okay? So nothing really trippy there. Just f of x and y are interchangeable. They want you to get that. Do you have it? Yes, ma'am? Can we move on? Good. Thank you. All right. So now just what does it look like on a graph? Can I tell you, I'm trying to make this, sometimes kids are confused. You know how we always had a little chart like this, x and y? If I asked you to fill out that chart from this picture, could you put a few points in there? Yes? It's the same thing, okay? But when we have this little 5 right here, would that 5 go on the x part or the y part? On the x part. So, oh, that's not what I meant. I meant to put a 5 there. So could you go find out what the y value would be on this graph? So wouldn't you go over here and you'd go, okay, so I'm going to trot over here to 5. What value goes with it? -2. Okay, good. So this is -2. So throw your -2 and the f of 5 equals -2. Okay, so when I get over here and it says f of -2, the next part right there, is that an x value or a y value? Okay, so put that in the x spot. Could you go find out where that was on the picture?
Yes.
Yes, you would trot over to -2 on the x. So you go over here. trot over to this point, and then you would go up to where? 3. Okay, put a 3 in there. That means that's a 3. You understanding? There's only x and y. Okay? Okay, f of 4. Is this an x or a y value? X. So you go to 4 on the x, and you would go down to 1. Wouldn't you? Be a negative 1 there? Okay, so it's not that complicated. It's just different notation. Write them as ordered pairs? Absolutely. Quick. How do you write part I as an ordered pair? 5, negative 2. This one will be negative 2 and 3. This one would be 4, negative 1. Correct? Are y'all in favor?
Yes.
Okay. How about part C? Everyone's good on part A and B. We're all good. And then C comes along and we're totally floored. Okay. Is f of x equal to negative 1? In my little chart over here on the edge, would the negative 1 go in for the x or for the y? For the y. It's not the x, it's the y. So you put a negative 1 here. Okay, in my little flow chart over there on the far left, I put the negative 1 into the y value. Then where would I go to find that on my graph? Let's go find it. So you would go down to negative 1 on the y. That would take you down here, right? You would go down here. And then where do you get, should I go left? Is there any function over here? No. Should I go right? Oh, yeah, there's the function. That's the line I'm looking for. Get it? I'm going to the line they drew. So I'm going over here, and what my y value, what would it be? 4. So I say that is 4. So x. Can you write x equals 4? By the way, it said find the value of x. So you know you got x equals. Okay, f of x is equal to 3. Is this an x value or a y value? It's a y value. Put it on the y side. Could we find it? That means you would go to where y is 3. So watch this. 1, 2, 3. Here I am waiting. I don't know if I should go left or should I go right? Both. Go both places. Positive 2 or negative 2. Both of them. You could put plus minus. Yep. And the last one, is this an x value or a y value? It's the y value. It goes on this side over here. So you go up to when y is 4. 1, 2, 3, 4. And then you try to go which way? Both ways, left and right. Plus 1 and minus 1. Yeah, you want to do the little sign thing, sure. Okay, we're almost done. Now, it says use the notation in part A to make a statement about the points A, B. So let's go get this. What is this point A, B? Someone tell me the coordinates of that. Okay, how do I write that with my F notation? F of what? Negative 5, because it would be an x. It would be the x. And that's going to equal 1. Talk to me about the point B. What are the values? What's the coordinates of that B point over here? 6, negative 3. Y'all in favor? Okay, how do I write that in function notation? I say f of 6 is equal to negative 3. It's just notation. It's nothing new. It's just this funky letters things that we got to worry about. Okay, last, here we go. Ready? Write the x and y intercepts of the graph of the notation. So let's find the x-intercepts. Here they are. I'll make them red. There's 2 x-intercepts right here and right here, right? 2 of them. Okay, what are the coordinates of that point on the far left? Negative 6 and 0. Let's write it as function notation. F of what? No, negative. It's always the x first, equals 0. And the other one, what are the coordinates of this one over here on the right? 3, 0. So how do I write that? F of 3 equals 0. Okay, those are the x-intercepts. Let's go find the y-intercept. What's the y-intercept? Come on, quick. Okay. How do I write that? F of 0 equals 5. Good. Okay. One last question for you about domain and range, which is really, really, really good. I'm going to get rid of all the little marks over here. Oh, no, don't do that. Okay, never mind. Can someone tell me the domain? What are you looking at when you look for the domain, by the way? The X. How wide is the window that this shape would fit in? What would your windows have to be on your calculator so that you would include the left all the way to the right? What would you say?
-6 and 7. Yeah.
From -6 all the way over here, all the way to 5, 6. I think they're right. They already put the little symbols in there. Notice the X such that we went from -6 to 7. X is in the middle. See all the symbols? You got to put all those in there. How about the range?
-4 and 5.
The very lowest point we get to is -4 and the highest is 5. Excellent work. Okay, I hope that domain and range becomes really easy. Okay, and I'm all done. So I didn't take long to do that lesson. So you have 2 lessons of homework to complete. Okay, there's just an X value and a Y value. That's all there is. It's just kind of some new notation.